Welcome to EDU World Space.
This question asks us to consider the isoelectronic ions fluorine minus and sodium plus. First, it asks us which ion is smaller. Since they're isoelectronic, they have the same number of electrons, therefore the same screening constant. So the only thing that's going to change here is the nuclear charge, and that's determined by the number of protons. Since sodium is further along on the periodic table than fluorine, it would have a greater number of protons, greater nuclear charge. That means the electrons are held more tightly, and a smaller atom. So sodium plus is the smaller of those two ions. Then it says, using equation 7.1 and assuming that core electrons contribute 1.0 and valence electrons contribute 0.0 to the screening constant S, calculate Z effective for the 2p electrons in both ions. So here's equation 7.1, Z effective equals Z minus S, or the effective nuclear charge equals the nuclear charge minus the screening constant. And so for F, the nuclear charge, or the number of protons, is 9, and for sodium, there are 11 protons. And then we're going to subtract the screening constant, which is the number of valence electrons, or the number of core electrons, times 1. In F minus, there are only 2 core electrons in the 1s orbital. So 2 times 1, 0.0. This gives us an effective nuclear charge of 7. And for sodium, it has the same screening constant because they're isoelectronic. So 2 times 1.0 for the 1s electrons gives us an effective nuclear charge of 9. Then in C it says to repeat this calculation using Slater's rules to estimate the screening constant. The screening constant for Slater's rules tells us that the electrons within the same orbital contribute 0.35, or in the same group contribute 0.35 to the screening constant, and those in the n-1 group contribute 0.85. And that's as many of the rules as we need to know to solve this problem. So the screening constant would be the number of electrons within the same group. So there are 7 electrons in this same group, other electrons in the same group. So 7 times 0.35 plus the 2 core electrons in the 1s orbital times 0.85. So then S equals 4.15. And that'll make solving for the Z effective a little bit easier. This is still Z minus S, Z minus S. The only thing that's changing is S as compared to part B. So this is still 9 and 11 for the nuclear charge, or the number of protons. Both of these minus 4.15. And the difference for each of these is 4.85 and 6.85. So with both calculations, of course, sodium plus has a greater effective nuclear charge than F minus. And then finally in D, it says for isoelectronic ions, how are effective nuclear charge and ionic radius related? And this we've seen throughout here. As you increase the effective nuclear charge, you're increasing the pull of the nucleus on the electrons, and therefore decreasing the distance between the electrons and the nucleus. So this would decrease the atomic radius. So you could say that these are inversely related.